Alright, let's focus on negative powers. So again, find the section in your note. This is section 2 that we're going to focus on negative powers. Okay, in your notes it says any number raised to a negative power is equal to the blank that you should fill in. Again, we should remember this from the discovery. It's equal to the reciprocal of the same power. Alright, so you have something like this, and this is the in numbers section of your note. So in numbers, if you have something like 3 to the negative 2 power, well, that negative exponent, and we could write this, remember, any number that's not a fraction we can write over 1, So what this negative exponent means to do is simply to flip. This 3 with the negative exponent of 2 was in the numerator. We simply have to flip it to the denominator. And once we flip it, that negative exponent just becomes a positive. Now, if there's nothing up there, we can assume that there's just a hidden 1 up there. And then, again, this is not simplified all the way because you have a number raised to a power, so this would simply be 1 over 9. And that would be your final answer to the original problem. In that same box, so you guys can just put a big slash like this, in that same box, if you have 1 over 5 to the negative 2 power, 5 to the negative 2, well, what would that be? The 5 to the negative 2 was in the denominator, so now we simply have to flip it so that it's 5 to the second in the numerator, and once you flip it, what happens to that negative exponent? It becomes a positive. What's left down there? Just the 1. And then 5 squared is 25 over 1. And then do we have to show 25 over 1? Nope, we can just show 25. Alright, so in algebra, this is the box in your notes. We can show properties like this. So if we have x raised to the negative a power, again, because x is raised to a negative power, we could say that x was in the numerator, so now we simply have to flip it to the denominator to get rid of that negative exponent. So it's x to the a power. Again, anything with a negative exponent just means to flip where it's at. If it was in the top, put it in the bottom. If it's in the bottom, put it in the top. So another example, you guys just draw a vertical line in that box here. What if you start with 1 over c to the negative d? Well, we got to get rid of this next negative exponent. How do you get rid of a negative exponent? You flip it. It was on bottom, now it's got to go on top. Really that simple. And then there's just a 1 down there. In that same box, you should have some room. I'm going to show mine over here because I'm out of room. Now, this is where we always trick you guys, this problem right here. Problems like this. And this is really important that you see the difference. If you have x to the third power, y to the negative 4. Now, what is raised to a negative power? Well, in this case, only the y is raised to the negative power. The x is raised to a positive power, so do we need to move that anywhere? And the answer is no. So that x, and you could have said, oh, again, anything we can write over 1. So this would be that x to the third stays in the numerator, right where it was, doesn't move. But what do we have to do with this y to the negative 4? How do we get rid of the negative exponent? Well, move it to the bottom. So it would be y to the 4th on bottom. Can't simplify it anymore. That's your answer. You guys have some room underneath that box, and let's get this key point down because this is a really, really important key point. And again, you're writing this just underneath that box. That the answer, the answer is not simplified. The answer is not simplified until all negative and 0 exponents are gone. Again, an answer is not simplified until all negative and zero exponents are gone. Okay, so let's do examples. Okay, example 1 is x to the negative 3. Okay, what would we do with that? Well, we got to get rid of the negative. Okay, this x to the negative 3, okay, if there's not a fraction written, we know we can write it over 1. So it was in the numerator, so we simply have to move it to the denominator. Once you move it to the denominator, that negative exponent turns positive. And don't forget to put the 1 up there. Okay. Example 2, we had 1 over x to the negative 3. Okay. You guys should be able to do this one. Give it a try. Okay. That x to the negative 3 was in the denominator. So to get rid of that negative exponent, we simply move it to the numerator. Okay? And do we have to show it over 1? No, we can just show it as x to the third. Just like if I have the number 8 over 1, do I have to show it as 8? No. Or do I have to show it as 8 over 1? No, I can just show it as 8. Okay? Alright, example 3 in your notes. It gives you 2 to the second power x to the negative 4. Okay, on this one, what has the negative exponent? Okay, and the answer to that is the only thing with the negative exponent is the x. So I have to move that x, it all was on top in the numerator, so now I just have to move the x to negative 4 down to the denominator. And guess what happened to that negative exponent? Turned positive. Once you move it, it turns positive. And then 2 to the second power. Am I done yet? Oh no, I know what 2 to the second power is. 2 times 2 is 4. So I'd have 4 over x to the fourth. Okay. Example 4. Okay. If I have x to the negative 4 over x to the negative 3. Now, I want to show you 2 methods of doing this. The first method, you should have room. Okay. Just show right off to the side there. Okay. When you are dividing, what do you do with the exponents? Again, when you're dividing, what do you do with the exponents of the same base? Well, you should have answered, you just subtract. So it'd be x to the negative 4, okay, minus, and then what's the other number? Negative 3. Okay. What happens with minus a negative? It turns into plus positive. Okay. So this would end up being negative 4 plus 3, okay, is x to the negative 1. Okay. And then what do you do with this x to the negative 1? Well, how do we get rid of the negative exponent? We flip it. It was on top. We move it to the bottom and just make sure we put that the exponent turns positive. That's it. Okay. Now, so that's the first method I just showed you is using the rules that we already know, just subtracting the exponents. And we subtract when we're dividing. Okay. But now let's use our negative exponent rule first. So you have room right underneath of that. This is method 2. Okay, let's write method 2. Okay, you guys should have a little bit more room than me. Alright, so I started off with x to the negative 4 on top. Okay, what should I do with that right away? Well, how do I get rid of the negative exponent? You move it to the bottom. And then it turns positive. You had x to the negative 3 on bottom. How do you get rid of that negative 3 on bottom? Well, you move it to the top. You flip it. Okay, and it turns to positive 3. Now we can still use our exponent rules. Okay, so this would be x to the 3 minus 4. Okay, which would be x to the negative 1, which is 1 over x. And you don't have to show that first power. Guess what? You get the same thing. So you can either use your division rules first and just subtract, or you can say, well, I just want to get rid of the negative exponents before I use that division rule. It's totally up to you. Okay, you'll find what method you make the most mistakes on and what one you work best with. Alright, let's do just a few more examples. Okay, so on the next page, this is example 5. Okay, starts off with 5 to the third power over 5 to the fifth power. Okay, well, I'm just going to use my whenever I divide. Now, a common mistake on this. I want you to stop and think. What do you think is the most common mistake on this problem? Okay. The answer is doing 5 divided by 5 and simplifying that. Okay. Why don't we do that? Well, remember, the 5 in this case is the base. There's no variable. The 5 is the base. We don't change the bases. The bases stay the same. Okay. We only change the exponents. Okay. So in this case, we do 5 to the 3 minus 5, because when we're dividing, we subtract the exponents, which is 5 to the negative 2. What do we do with that? Well, we put it was on top, right? We can write anything over 1, but we flip it. To get rid of that negative exponent, we move it to the bottom. So it would be 5 to the second power. Now, are we done with that? The answer is no. We know what 5 to the second power is. It's 1 over 25. And I actually don't like those sideways fraction bars. So 1 over 25 would be your final answer. Okay. Example 6. Example 6, 7 to the negative 3 over 1. Okay. Now we've kind of already gone over these. This one should be simple. Okay. How do we get rid of that 7 to the negative 3 on top? Well, we got to get rid of the negative exponent. So let's move it to the bottom. So it turns into 7 to the third power and bottom. Now you may be saying, well, what about this 1 down here? Well, if you want, you can show that you're multiplying that 1 times 7 to the third. Okay. And then if nothing's there, what do we put in the numerator? Okay. We've already gone over this. Put a 1. Okay. And then 7 to the third power, and if you want to say times 1, okay, that's fine. Again, if you want to say, well, you can't forget about this 1, multiply by 1, knock yourself out. It's not going to change a thing. Okay, so we'd have 1 over 7 to the third power is 343. That would be your answer. A couple more examples. Example number 8. This is example number 8. Okay, x to the 4th over x to the 7th. Okay. Well, there are two ways of doing this. Let's write out the long way so we can refresh our memory on where these rules came from. So x times x times x times x over x times x times x times x. And then I need, how many more do I need? 3 more. 2, 3. Can I count to 7? 1, 2, 3, 4, 5, 6, 7. Yes. Okay. What happens with these? Well, cancels, 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 cancels. Okay. What's left? 1 over x times x times x. Well, what is x times x times x? Well, that's going to equal 1 over x to the third power. If I could draw 3. 1 over x to the third power. Okay. Now, I want you to get that down, that way down. But below that, let's use the rules. And you guys should have space to write this below. When we're dividing, what do we do with the exponents? We subtract them. So it would be x to the 4 minus 7, which is x to the negative 3. Okay, we cannot leave it with the negative exponent. Okay, so that would be turn into 1 over x to the third power. Again, this x to the negative 3 here, remember, if a number's not written as a fraction, you can write anything as a fraction over 1. So that told us it was in the numerator. How do we get rid of the negative exponent? Move it to the denominator. Okay. Let's do example 9. Okay. We have w to the negative 6 over w. Okay. Well, let's start off by, let's start off by getting rid of negative exponents first. Okay, there are two methods we're going to do for this one. So if you said, oh, first thing I want to do, get rid of negative exponents. Okay, well, how do you get rid of this w to the negative 6 in the numerator? Move it to the denominator. So you have w times w, and once you move it, it becomes a positive. Okay, and there's a hidden 1 there. So how many w's are on bottom? Or when you're multiplying, what do you do with the exponents? You add them. So it would be w to the 7th power. Okay. We could also use rules. Okay, so let's use rules of division. Okay, if we do that, we would have w. When we're dividing, we subtract the exponents. There's a hidden 1 there. So we have w to the negative 6 minus 1. and that equals w to the negative 7. How do we get rid of w to the negative 7? The negative exponent, well, it was in the numerator. We move it to the denominator. You notice, both ways you get the same thing. And again, those two options work. One, you can say, well, I want to start by just getting rid of negative exponents. Okay, so what do we do to do that? We moved it. Okay. Method number 2 is you can say, well, I'm dividing, so I don't care if I have a negative exponent. I'm just going to use my rules, and when I'm dividing, I'll just subtract. Okay. Either method you can use. Fine. Okay. Find out what works best for you. All right, so let's do example 11. Example 11. Okay. We had x to the negative 2, y to the 3rd, and z to the negative 4, all over a to the negative 3. Let's get some steps down. So in the upper, or in the lower corner there, let's get step 1. Let's flip any negatives. Okay, because there's nothing that we can subtract of exponents here. There are no similar bases. A isn't the same as any of those other bases up here. Okay, but we still can't keep negative exponents. And then 3 will just be to simplify. And there are a few things involved in simplifying. Okay, so let's do this one. Alright, so first I'm going to write out, and with this flip any negatives, very first thing you should do is write out a fraction bar. Because in order to flip, you need to know whether it's on top or bottom. So that x to the negative 2 was on top. Where do you think I move it? Move it to the denominator. Y to the 3rd, does that need to move anywhere? And the answer is no, it stays. Okay, so if you want to put a note here that just says stays, okay, it's positive, so it stays. Z to the negative 4, well, it was on top, it's negative, so I got to move it to the bottom. When I move it, it becomes positive. Okay, this a to the negative 3, it was on bottom, so now I got to move it where? To the numerator. Okay, and once you move it to the numerator, it becomes positive. Now, you should always put things in alphabetical order. So I'm going to rewrite my fraction. What comes first in the alphabet, A or Y? I'm not even going to give you any time to think about that. If you did not know that, come see Miss Declan or I after school. Okay, and then what comes first, X or Z? X does. So X squared, Z to the 4th. Okay, so that is the answer. In alphabetical order, no negative exponents, no zero exponents. Okay. Alright, example 12. Example 12. It gives you a to the 3b squared over a b to the 5th. Okay, and it says is equal to a to the x, b to the y. Okay, and it's asking you, what is x times y? Okay. Well, that means we have to figure out what x and y are. Okay, let's look at x. Okay, x, and you guys probably have room to write this above this. I'm going to write it below it for sake of space, but again, you guys can probably draw your arrow from above. Okay, x is exponent on a. You see that? X is the exponent on a. Okay. Y is the exponent on what? Well, it's the exponent on b. So let's use our rules to figure out what the exponents are on a and b. So a, when we're dividing, we subtract. I'm going to put that hidden 1 in. So it would be a to the 3 minus 1. So a is equal to 2. And b is equal to 2, oops, let me erase that. B is, let's see, 2 minus 5, so b is equal to negative 3. Okay? Or I'm sorry. Let me fix that. Go back and change this. Go back and change this. My apologies. Okay? This is a to the second power, right? Because we can't forget about the base of a. Okay, and this is b to the negative 3. Okay. Now, you may be saying, but Mr. Irwin, you said you can't have negative exponents. You're right, you can't. But if we look at this, okay, this b right here is in the numerator, right? Both of these are in the numerator because you could show them as over 1. Okay, so we have to keep this b in the numerator to really compare them. Okay, so in this case, all it's asking is when you have b in the numerator, what's your exponent? Okay, that's what this is saying right here. When you have b in the numerator, what's your exponent? Well, when we have b in the numerator, what's our exponent? It's negative 3. So all we have to do is plug in. So again, my y is negative 3, and my x is 2. So it would be 2 times negative 3, and that will equal negative 6. That's the answer for this one. Okay. If you're still really confused on this, make sure you write out your question and ask it when you get to class. Okay, last example I'm going to do is on the next page, and it's number 9. You guys can get this down. It gives you 2p times 4p to the negative 1 times 4p to the negative 3. Okay, and it's all over 2p to the negative 2. Okay. First thing that we should do, the very first thing, is simplify the numerator. Okay, we can simplify the numerator. So when we're multiplying, multiply the coefficients. So 2 times 4 is 8. 8 times 4 is 32. 32. And then the p's, well, we have a positive 1. What do we do when we're multiplying? What do we do with the exponents? We add. So we have 1 plus negative 1 plus negative 3. Okay, all over the denominator we don't do anything with right now. Let's just leave 2p to the negative 2. Okay. Again, we don't want to move things before we've simplified the numerator and denominator. That's a really important point. We don't want to move things until we've simplified the numerator and denominator with these really tough problems. Okay. So I'm going to bring my work down here. Okay, this would be 32, and you guys should have room to go sideways. If not, just go right down below. I'm going to start over a little bit further. So 32. Let's see, 1 plus negative 1 is 0. Okay, plus negative 3 would be p to the negative 3. Okay, all over 2p to the negative 2. Okay. Now, what do you do with these coefficients? 32 divided by 2 would give you 16. P to the, when I'm dividing, I subtract. So negative 3 minus negative 2. So important that you keep this minus, and I like to put this negative 2 in parentheses. Okay? What happens with this? Turns into plus positive. So you end up with 16p to the negative 1. Okay? Are you done? No, you have negative exponents. You cannot have a negative exponent in your answer. So how do we get rid of, and keep in mind, okay, if it helps you, what's the exponent on 16? You should say 1. Okay, if there's nothing there, there's a hidden 1. Just like if I draw the number 8, what's the hidden exponent on an 8? 1. Okay. What's the only thing with a negative exponent? Well, it's only the p. The 16 does not have a negative exponent. So the 16 stays in the numerator. This p to the negative 1, we move to the denominator. Okay? And that would be your final answer.